Hello there, ROS developers, and welcome to this live class number 114, where we are going to be talking about basic C++ using C++ for robotics. So let's start. Alright, so hello there and welcome everybody to this new live class. As I have just said, we are going to be talking a little bit about C++. Specifically, we are going to be checking arrays and pointers, so how to apply them to robot programming. So yeah, welcome everybody. I have seen here in the chat that you have been already having a very interesting discussion about either to use C++ or Python for ROS, for programming ROS. So yeah, super interesting, and yeah, I have been seeing and I totally agree with everything you said. So both can be used. In my opinion, Python is easier in order to learn ROS because it's going to make all the programming part easier. And C++ has other advantages, like it's faster, it's compiled. So yeah, in case you are starting to learn ROS, I would suggest you start with Python. It's my opinion. It's going to make easier the process of learning ROS, unless you already know and have a good level in C++ programming. Then that's another case. In any case, okay, so let's start. So welcome everybody. Let me know, first of all, if everything is fine, if video is fine, audio is fine, so we can keep going. Let me know here in the chat. Hello, Engineering Nations. Hello there. Let's see. Everything is fine. Everything is great. Audio and video are fine. Okay, excellent. Thank you very much. So let's go for it. Then, yeah, so in case there are any new people here to the live class, so in case this is your first live class, in the last live classes I've seen that there is some new people coming. So that's why I always want to explain a little bit what's this about. So basically we are going to do a live class. I'm going to show you some concepts of C++, apply it to a practical example, in this case using ROS and using a gazebo simulation. But the most important part of this is that I want this class to be interactive. So meanwhile I'm going to be explaining and doing different examples, etc. I want you to be doing that with me. So I don't want you to be right there just watching and listening to me and to what I am doing, but I want you to be working with me. Let's say like this, so that we all together are advancing on the different things that we are going to be doing during this hour, because this is the way that you are going to really learn and get something from this live class, which is the final goal, that you get something profitable, so that you get some kind of profit from this live class. It can be knowledge, whatever. So let's go for it. Then I'm going to start right now. Let me switch my screen here to the computer. So as always, we are going to be working here in the Construct platform. So the first thing I'm going to do right now is to share with you the project of today's live class, which is going to be this one. Then what is a project? Well, a project basically is a ROS project, let's say. So this contains everything that you need in order to develop a ROS project. So it has you can use all the tools like IDE, Gazebo Simulator, web shells, etc. And basically this one is already prepared for this purpose. So it contains the packages related to the simulation, a notebook that we are going to be following, etc. So let me share it real quick here. And I'm going to share the link here in the chat. There we go. Okay, so what to do with this link? Well, super easy. So first of all, you need to be logged in into the construct here. So in case you already have an account, just log in. In case you don't have an account, just create one. It's free and it's going to take you just a few seconds. Then once you are logged in, you can directly click on the link I have passed here in the chat. You can copy and paste the URL also here in the URL bar, whatever you want. The thing is that once you do that, you are going to receive here in the My Projects section, you are going to receive a copy of this project. It's going to be exactly the same. Yeah, so you're going to get this one. Probably you are going to have all these different, depending on what is your workspace, if you have been working on other projects or not. But you are going to receive this one. ROS Developers Live Class number 112, Basic C++ for Robotics, Arrays and Pointers. All right. Then, so once you have this project here in your workspace, in order to launch it, all you have to do is to click here on the Run button. So let me do it right now. And this is going to start loading the environment. So as you can see, it automatically opens here the Jupyter Notebook window. So this is going to contain the notebook that we are going to be using in order to follow today's live class. So it's going to contain instructions, some theory, so that you can follow it at your pace also. Then meanwhile, this keeps loading. It might take some seconds, even 1 minute, a couple of minutes at most. So meanwhile, this my project loads. I want you to, as always, remember you to have a look at our academy. So right now we have divided the construct page into two main sections. One is the development studio and the other one is the academy. So the academy, as the name indicates, its purpose is to teach. So here you are going to find basically all the educational material. You're going to find many different courses related to robotics theory, related to ROS, different specific ROS topics like navigation, perception, manipulation, whatever. So you are going to find many different courses. Also, you're going to find ROS2, by the way. So for instance, here you can see ROS2 Basics for C++, which is going to use Foxy. Yeah, so basically you are going to find all the courses. Also, we have a course here. Let me find it. We have it here in the basic ROS. So basically here you're going to find as well a course on C++ for robotics. So we have some free courses. In this case, the free courses are Linux for robotics, Python 3 for robotics, and C++ for robotics. So these courses are the code foundation, let's say, in order to start learning ROS. So if you want to learn ROS, you have to know, yes or yes, at least two of them. So you need to have a basis on Linux, and you need to have a basis on either Python or C++. So this is why we are offering these Code Foundation courses for free, so you can get this basic knowledge on Linux and on Python 3 or C++. So yeah, feel free to check them, to start them. As I have just said, they are for free. There are other courses that are you're going to need a subscription to access them, but these ones are for free. So today's live class basically is going to be related to this C++ for robotics course, let's say. Okay, then yeah, so let's come back here. So here my Jupyter Notebook has opened. Let me click here in the default button so that I can open it. There we go. Okay, so here I have my notebook loaded. So here, as you can see, we have many instructions that we are going to be following during today's live class. So actually, I don't know why it has opened it here in a different... Okay, well, in any case, you can, maybe it opens directly automatically here in this window. In my case, I'm opening it here in a different window so that I have it bigger. So, so yeah, then once we have done this, let me close it here. The next step is going to be to start the simulation that we are going to be working with, which in this case, it's this simple world with a wall here and a ROS-bots 2.0 robot here. So in order to start the simulation, all we need to do is to follow the instructions that we have here in the how to launch the simulation section. So first of all, we are going to open a web shell by clicking here in the web shell icon. There we go. Then now what I'm going to need to do is to source the ROS version, which in this case it's noetic, so that I can start using ROS commands. Next, I'm going to source the simulation workspace, which is this one here. Why this workspace? Well, because within this workspace is where I have placed all the simulation gazebo related packages. So here, besides the web shell icon, we have the code editor icon, which we can click as well. And this is going to open the code editor, the visual code editor. And here you're going to find all the different workspaces that we have. In this case, the simulation workspace, if we go into it, you're going to see that we have some packages that I have already placed here, which are going to allow us to launch this gazebo simulation. So that's why I need to source this workspace also. Then finally, I'm going to launch this command, which is the ROS launch command that is going to start the simulation. So let me copy it directly here from the notebook and run it. So now I can come here to this cube-like icon that I have here and directly click it. And this is going to open the gazebo window. So in this window is where I'm going to be able to visualize the gazebo simulation. Here I have it. So here I can see my ROS-bot with the world. So once I have the simulation loaded, what I'm going to do is to minimize this web shell so that I don't close it by accident or anything, because within this shell is where I have the gazebo simulation running, so I don't want to close it by accident. Then I'm going to minimize it, and I'm going to click here in the web shell. I'm going to click on the plus icon, so I open a brand new shell, which is the one I'm going to use in order to work. So yeah, basically I'm set up here. So I have already loaded my notebook, which I'm going to be following for the instructions. I have also already started the gazebo simulation, so I have everything ready to start the live class. Then let me know here in the chat as well if you are in the same point as I am or not, if you had any issue or anything. How much time will this class take? It's going to be 1 hour until 7 p.m. of here Barcelona time. Do project expire? Asks RCM. No, RSM. No, this project. So once you get this project in your workspace, you are going to have it forever. So you are going to be able to open it tomorrow if you want and review it. No, it's not going to disappear from your workspace. Is it the same project shared in previous class? It's very similar, yeah. So it's very similar to the live class we did 2 weeks ago. So basically this live class is going to be a part 2, let's say, of the live class we had 2 weeks ago. So it's more or less the same, but with some updates, yeah? Is it possible to completely reset the prerequisites exam, the one you can complete after I did the free courses? Several files seem to be missing. I don't quite get your question here. To reset? You can do that exam as many times as you want, the prerequisites exam. In any case, if you have any specific issue, Kupofti, I suggest you to place it in the forum, because there it's where we are going to be able to give you a better support than here in the live class. Okay, so I suggest you place, in case you have any question about the prerequisites exam, any issue, whatever, I suggest you you put that in our forum. Okay, all set. I want to ask if we can have multiple ROS distros installed. Yes, it's possible, Joannis, it's possible. It's possible to have different ROS versions installed. Is that possible? Mohamed is asking, is that possible to follow the steps and just see what you do? Yes, it's possible. You can do that if you want. But I suggest that you try to reproduce the steps yourself. I really recommend to try to do that. To try to do what I am doing, to reproduce the same steps that I am doing. At least if it's not right now, because you prefer to see and check what I am doing, I suggest that you do it in another moment at your pace if you want. That's also possible. But I suggest that you try it at least. Okay, so I assume that everything is fine, guys. So you have loaded your ROSjects, you have started your simulations, everything is ready so that we can keep going. Yeah. It's about gemapping? No, this live class, it's not about gemapping. It's about C++ basics, specifically about arrays and pointers. Okay. Okay, well, let's go for it, I guess. So I'm going to start with it. All right, so let's come here to the ROSject, then let's come right here to the notebook. So we are going to start by the beginning. Then related to this first part of variables, arrays, I'm going to do it fast, since this is more or less what we did in the previous live class, in live class 112. So I'm going to go over this faster. Then, yeah, so variables and addresses. So when in C++, when we declare a variable, it gets automatically stored in the computer's memory, in an address, which is in our memory. Yes, then in C++, we first declare the variable, and then later we assign it a value, like we can see here. So in this case, we are declaring this variable, which is named my variable, which is of type int, integer, and then we assign a value, which in this case it's a 42. Then when we declare this my variable with a value of 42, we can access this value, which can be done like this, by just putting the name of the variable. Then with this, basically what we are going to get is the value, which is stored in this variable, which in this case it's 42. Yes, but we can also access with the ampersand sign here before the variable name, we can access the memory address where this variable is located, which is going to do a hexadecimal number usually. So we are going to show it now. Then here we have a graphical image of this. So basically when I declare a variable, like I'm doing here, int my variable, and I assign a number, basically this is going to put this variable into a memory address, into an address in our memory. We can think of the memory as a list of different, many cells of memory which are numerated, let's say, let's call it like this, cells. Then in this case, when I'm declaring a variable, I'm going to store it within this cell. So here, as you can see, in my variable, I have the value of my variable, which is 42, and down here, I have the memory address of this variable. Yeah, so let's create here a very simple program quickly. Here, so I'm going to come here. Now I'm going to start working on the Catkin workspace. Yeah, so here I have already placed this folder, which is CPP live class. Then I'm going to come here to the utilities folder, and I'm going to create a new file, which I'm going to name, let's say, test.cpp, okay? Then I'm going to paste my code here, the code I have here. I'm going to copy it and paste it directly here to the code editor. So now I'm going to compile it. Yes, so this is one of the differences in, because the discussion I saw previously there in between Python and C++. So in C++, any program that you create, you need to compile it. Yes, in Python, that's not necessary. So this is an important difference between C++ and Python. So let's come here to the CPP live class utilities folder where I have created this test CPP file. So now here at the top of the notebook, here in the remember section, I can see the instructions how to compile it. Yes, so once I am here in the directory where I have created my file, I can compile it using G++ in this case. So I'm going to compile it directly here from the shell. Oops, I didn't copy properly the command. Put this like this. Then here I'm going to indicate instead of file CPP, I have named my file test CPP, right? So I'm going to modify it here in the command test CPP, and I'm going to name the executable generated as test compiled. So let me run this command. And once I have done this, I can see that from my test CPP file, here an executable file has been generated. Yeah, so now I can run this executable file, for instance, like this. Yes, // and the name of the executable. So this is going to execute my executable, which has been generated from this test CPP file that I have created here. So basically, as you can see, the program is super easy. So I'm just here declaring a variable named my variable, which I am assigning a value of 42. Then I am printing first the value, and then I am printing the memory address using this ampersand before the name of the variable. So basically, if I run this, what I'm going to see is first the value of the variable and then the memory address, which, as you can see, it's this one. Yep. Okay. Then let's keep going. Let's keep moving. Okay, we have gone through this. Then arrays. So arrays is something which is very interesting in C++. So an array basically is a series of variables, let's say, of the same type, which are placed in contiguous memory locations. Okay, so I can declare an array like this, for instance, or I can declare an array like this and initialize it to a list of values. Yeah, so this is the size of my array, which in this case is going to be 6, and here I'm initializing it and I'm giving it 6 integer values in this case, because my array is an integer array, so it has to contain integer values, right? I cannot assign here float values, for instance, let's say. All right, then what is interesting of arrays is that we can access each different element in our array. So as we can see here, we are accessing the element 2 of the array. Then this is going to print us the value 15, which in this case it's the third value where we have declared. So let me put this into the code. So I'm going to modify this code here. I'm going to initialize my array, and I'm going to print here. Let me comment this and print here the value in the position 2 of my array that I have just declared and initialized it here. Then let me recompile this. Oops. And run it again. All right, so as we can see, it's printing the number 15, which actually it's the third number in our array. So this is because, why is this happening? Why it's not printing the number 8? Well, because arrays, the first element in an array, it's considered the position 0 of this array. It's considered the 0 element. So if I change, for instance, this to the 0 element, I'm going to access the value 4 of my array, the first element in this case of my array. So this is the element 0, the number 8 is the element 1, 15 is element 2, etc., etc. So for instance, if we recompile this and run it again, now we are going to get the number 4. Yes, so this is an interesting characteristic of arrays, which can be at some moments confusing if you are new to C++, so it's worth telling it. Then we can also, for instance, like we can see here, we can iterate over all the elements of an array. So we can start from the 0 element and then iterate and go over all the elements of an array using for loops, using while loops, using at the end loops. Yeah, so we are going to see an example here. Well, not right now. We're going to see an example of this later. So right now what we are going to see is an example using the simulation, which we already saw in the last live class. So we are going to go over it pretty quick as well. So let me directly get this laser readings.cpp code. I'm going to copy directly here from the notebook, and I'm going to create it, in this case, inside the C scripts folder and inside the src folder. I'm going to create a new file and name it laserreadings.cpp. There we go. And here I'm going to paste this code. Okay, so now let me open here the semi-glitch file and check that yes, so we have this laser readings here in the semi-glitch file, so we are going to compile it. Then as you can see here, we are already using some ROS elements. Yeah, so basically this laser readings function, it's importing this ROS-bot class, which you can have a look at it if you want here inside the ROS-bot control folder src. You have this CPP class, which basically it's a class which provides helper functions in order to interact with the robot. So we have different functions, as we can see here, to move the robot, to move forward, to move backwards, to turn also, to stop moving, get position of the robot, get laser, get the complete laser readings, etc. So basically it contains many helper functions related to this simulation and this robot. Okay, so in this case, in our laser, you can have a look here. I'm not going to explain it right now, so you can have a look at this code if you want, if you are interested. Then in our program that we have just created now, the laser readings, basically we are going to use some of these functions. Then as you can see, we are creating our main function. We are here creating an element of the ROS-bot class, and we are calling, in this case, first of all, the move forward function. So we are going to move the robot forward for 3 seconds. Then here, in this case, what we are doing is to call the getLaser function. This getLaser function is going to return us a specific value depending on the number we pass here as an argument to this getLaser function. So here we are passing first the number 121 and second the number 431. So basically this number makes reference to the laser beam. We can see this in the notebook. So as you can see, this ROS-bot 2.0 has a laser mounted on it. We can see it here, this cylindrical black element that we have here. This is the laser, and it has a range of 360. It has a scope, sorry, of 360 degrees. Then, depending on, basically, we can consider all these as different laser beams, and each one of these beams, of course, is going to return a different value depending on if it finds an obstacle on its way or not. If it doesn't find an obstacle on its way, it's going to return an infinite value. If it finds an obstacle like this wall, in this case, it's going to return the distance from the laser to this wall. Yeah. Then basically we can we are storing all these laser values within an array. Then the position 0 of the array, the first element, is going to be somewhere around here. Yes, near the front area of the robot. Then it's going to keep increasing clockwise, in this case, until it reaches the last position, which is the element 719, which is going to be also around here. So more or less in the front of the robot. Okay, so in total, this array is going to have 720 positions. Each one of them corresponding to a different laser value and laser reading. So in this case here in our program, we are getting the position 121, which is going to be somewhere around here, probably, and the position 431, which is going to be somewhere around here, right? All right, then finally what we do, so we declare an array here of 2 positions, in this case, where we are going to store these 2 laser values, and then finally we are going to print these values. So we print the first element and we print the second element. The first element corresponds to the left value, to this one, and the second element corresponds to the right value. Yeah? All right, so let's compile this program following the instructions that we have here. So we are going to come to the Catkin workspace, compile using Catkin make. Then we are going to source Catkin workspace, and now we can run our program using ROS1 like this. So basically this is going to start moving the robot forward for 3 seconds, and then it's going to return me the values here that it's getting from these getLaser functions. So let me run it and see what it happens here. So the robot starts moving forward. Here it stops and it returns me the values, which I can see it's infinite for the first one. So the first one, which the first element in my array is the left value, which corresponds to the position 431, which is somewhere around here. And around here, in this direction here, we don't have any obstacle, any element, as you can see. So, oops, sorry. So on this direction here, we don't have any element, as you can see. So it makes sense that I am getting an infinite value, right? Then for the other one, I'm getting 2 meters. So for the right element, I'm getting 2 meters, which corresponds to the position 121, which it's going to be somewhere around here, this direction, right? So in this direction, here we can see that it's going to be more or less here colliding with the wall around here. So it makes sense here that it's getting me, it's returning this value, okay? Because it's finding this wall somewhere around here. Yeah? All right, then, yeah, so super basic example here, using some helper functions, storing them in an array, and then printing the different values. Okay, so you can play with these values, change the numbers, and see how this program changes. That's up to you. I'm going to keep going. So I'm going to keep going here through the class, and then I'm going to start here on pointers. So basically, we have seen previously here in the notebook. Let me get a quick drink here because I'm getting my throat super dry. Okay, let's go back. Then, yeah, so we have seen here in our program, we have seen how to access, in this case it was done like this, how to access the memory address where my variable is stored, which it's using this ampersand before the variable name. Yes, but then there's a variable where we can store this kind of data. And this variable is known as a pointer. Yeah, so the type of variable that can store the memory address of another variable is called pointer. Yes? Then pointers are declared like this, with the operator, with this asterisk here, like you can see here. Okay? Then if we want this pointer to store the address of our previous variable, my variable, we just need to give it the value of its address, like this. So super easy. Then we can declare, let's try this, actually. So let me copy this line here, and I'm going to add it here. Well, let me go back to a previous version, my variable. There we go. Okay, so here I'm declaring my variable, then right here I'm going to declare my pointer. Yes, with the asterisk here. Then I'm going to give the value. Let me copy this line here. So here I'm going to assign the memory address of my variable to my pointer, right? And I'm going to, let me comment this and add this here. Oops, sorry, I haven't copied it. Yeah, I wanted this line. There we go. Okay, actually, let me not remove this. We are going to be able to see the difference. So, what I am doing here, I'm initializing my variable to a number 42. I am initializing here my pointer, and then I'm assigning to my pointer the memory address of my variables. You can see I'm using here the ampersand before the variable name, yes? Then here what I'm going to print first is the value of my variable, which is 42. Next, I'm going to print the memory address where my variable is stored, right? Using here the ampersand. And finally, I'm going to print my pointer. So what I expect here is that my pointer has the same value as this variable with the ampersand, which is the memory address, actually. Yeah, so I expect to get first the 42 value, and then I'm going to print here the memory address, and again, the pointer, which is the same value of the memory address. It should contain the same value, right? Then let's compile this. Let's come here. Where do I have this? Actually, it's in CPP Live Class Utilities, right? Yeah, here I have it. So let me recompile one more time here this program and run it. And so yeah, here we can see that we are first printing the value of my variable, then we are printing the memory address, and finally we are printing the pointer. And the memory address happens to be the same as the pointer, right? So in our pointer, we are basically storing the memory address of my variable, right? Then what else? Yeah, so we can also print, using the pointer, we can also access the value of the variable. This is done like this. Let me add it here in the program. So if we put an asterisk here before the pointer, this is known as dereferencing. And like this, I'm going to actually access the value of the variable. Yeah? So if I use the pointer like this, I'm going to be actually using the memory address. But if I put this asterisk because before the pointer, I'm going to actually be accessing the value of the variable. So let me very quickly here recompile it and execute it again to see how now, using this asterisk here, I am actually accessing the value of the variable from my pointer. Yeah, makes sense? All right, then let's keep going. Yeah, so let's add this. So we can use the pointer, of course, to change the value of the variable. So let's come here and let's add this down here. So I can reassign here using the pointer with the asterisk, I can change the value. Yes? So if I print it here, this is going to have the value of 42. But I can reassign this to a different value, let's say 23 in this case. And now, if I print again my variable, see, so here what we are changing is the pointer, right? We are changing the pointer. And here we are actually printing the variable. But if we compile this and execute it, let me compile it and execute it to show you this. So actually, as you can see, it has changed the value of my variable. So actually here, with this, we are actually accessing the value of the variable and modifying the value of my variable, as you can see here. Yeah? So using the pointer, we can access the memory address, but we can also access and modify the value of the variable. Yeah? All right. You have a graphical illustration here of what we have just done here by changing the value of the variable using the pointer and using this dereferencing property. All right. Then here we have been using the pointers with a single variable, but we can use pointers also with arrays. So let me change the code we are working with, so that instead of declaring a variable here, I'm going to declare an array again. Okay, so I'm going to declare my array, which has 6 elements, and I'm initializing it to these 6 values. Then I can, so here I'm declaring my pointer, and I can also assign my pointer to the array. As you can see, when I assigned an array to my pointer, it's not necessary to add the ampersand like I was doing here. Yes? So here I am assigning my pointer to my array. Then actually, by doing this, what I am... So here it's very clear because we only have a variable, right? So we have only one variable. So when I assign a pointer to my variable, I'm actually assigning to the address of this variable, which is only one. But in an array, we have many different variables, right? So to which one is my pointer going to be pointing? Actually, it's going to be pointing to the first element, as we can see here. So when I assign a pointer to an array, I'm actually pointing it to the first element of the array, which is the element 0, as we have explained it before, right? Then, for instance, let me get this line here. Let me comment all this. We have many things here. Comment all this, and let me just print this. All right, so we are declaring our array, we are declaring our pointer, then we are assigning our pointer to the array, and then here we are accessing the pointer with the position 2. So actually what we are doing here is to, we are pointing to the second element, which actually is the third element of the array, which is 15. So actually here what we are going to do is to print the number 15, right? So let's see this. Let's recompile our test program and print the value, right? So as you can see, the main pointer is actually pointing to the first value of the array. Then we can move through our pointer in the same way that we were doing with the arrays, by entering here the element we want to print. So remember that the 0 element, actually, if I print here my pointer, let's do this without any element. What we are getting is the memory position of the first element, right? We are getting the memory position of the first element of our array, which in this case it's 4. Yeah, so we are getting the memory address of this 4 number, right? But if we specify, if we specify here, where do I have it? There we go. There you go. We put the 0 here. Then I'm going to print actually the number 4 instead of the memory address, right? So let's recompile, run it, and now I'm getting the number 4. Yeah, makes sense? So we can use pointers with variables and we can use pointers with arrays as well. Okay. Yeah, so more things. We saw previously in single variables that we can modify actually the value of the variable using our pointer, right? So we can do the same using our array. We can do exactly the same. So, for instance, if we do this here, what do you think this is going to do? What do you think this line here is going to do? Let me know in the chat here. What do you think that is going to do, that line of code? What compiler does the Catkin make use? It uses CMake. Mohammed, it uses CMake. So does somebody know? Yes, no, yes, no? Okay, let's change the first value of the array to 10. That's right, that's right. So this actually, so my pointer here is pointing right now at the first value of the array. So this is going to change the first value of the array to 10, right? So now if I print this again, let me do this. Let me compile here and run it one more time. So we can see that we get a 4 and a 10. So initially here we are printing the element 0, which is the first one. So we are printing a 4. And then here we are accessing the first value in this case, because we are not providing any extra information. So we are accessing the first value of our array using our pointer and modifying this to 10. Then if I print again the first element, I can see that it has changed to 10. Yeah? Makes sense? All right. Then we can do many different things here, many operations with the array. So for instance, we can indicate to advance one position with operator ++. So actually this, what it's going to do is to move from the first position of the array to the next one. So let me use it here in the code. So for instance, if I do this, what I'm going to do is to move my pointer from the first element, which is here, to the second element, which is 8. Then now I can modify again. So let me show this. I'm going to access the first element and the first element, okay? So here, basically, what I have done is to move from the first element of the array to the next one, using this ++. This is very common in C++ to use this ++ structure for incrementing, especially in loops, in for loops, in while loops. This is very common to use. So in this case, it's used in pointers in order to move also. So I'm going to move from the first element to the next one of the array, right? Then I'm going to print it, which is an 8. Then I'm going to modify it to a 9, for instance, and then I'm going to print it again. So I expect to get first an 8, and then here a 9. So let me compile this. And actually I'm getting a 15 number. Oh, right, that's right, yeah. You know what has happened here? Does somebody know in the chat what has happened? So basically, I have moved my pointer here from the first element of the array to the next one. So now this element, so my pointer is pointing to this element here. So actually, if I want to modify this value, what I need to change is I need to access the 0 position, right? Because now I have moved here, doing this, in this line I have moved my pointer from the 4 number to the 8 number. So now the 8 number, actually I access it like this. And if I put a 1 element here, I'm going to access the 15, not the 8, right? So now, yes. Yeah, so did you understand? This is quite interesting, and it's something that it's good that it has happened here, because we can see this. We can actually see the use of this in first person. So actually we are moving the pointer from here. So at this point, it's pointing to the first element, right? But if I use the plus, I'm going to move the pointer, and instead of pointing to the 4, it's going to be pointing to the 8. So now the 8 number is the 0 element of the pointer, not the 0 element of the array. Yeah? Okay. Let me see here. Where we can use pointers in robotics, I can see here, Ioannis, that's super good question, and this is actually what we are going to see right now. Okay, so in order to end this live class, so okay, so yeah, yes, Alberto, these pointers are super cool, but how can I use this in robotics, or how can I use this in my ROS programs? So let's move this. Here we have some examples. Let's skip all this and move to the final section. So how can we do here to the pointers in functions? Okay, so how can we use this in robotics? So this is very useful in ROS programs and in robotics, let's say, in order to make our programs much more efficient and to optimize our programs. So let's see a scenario. So we are going to be working now, we are going to do a test with the robot simulation, which basically is going to show us this. How can we use this, and how can pointers help us in robotics and in our ROS programs? So, okay, so come here to the final part of the notebook and find here, detect this laser readings full CPP program. So all of you come here to the final section. As you can see, it's almost at the end of the notebook. Come here and focus on this laser readings full.cpp. So I'm going to create a new program here in my workspace inside the C scripts folder SRC, where we have created previously the laser reading CPP. I'm going to create a new one, which is going to be named laser readings full.cpp. And inside this new CPP file, I want you to copy this C++ code, okay? Let's do this. Then, this is basically a modification of the laser readings we created previously. So here we were accessing some specific values, some specific beams, let's say, of our laser. So now what we are going to do here is to call the get laser full function, which actually is going to return us all the values of our laser. So all the 720 values of the laser. So we are not going to access only one, but we are going to access all of them, okay? We want to access the 720 values of our laser. Then, in order to do this, what we are going to be doing is to call this getLaserFull function, which is in our ROSBot class file that we have checked at the beginning of the class, you remember? So here, I told you that we have some helper functions. For instance, we have these getLaser functions right here that we used in our previous command, in our previous program, in these laser readings. Here we have the getLaser function, where we pass an index and then it returns a specific value. But here we have this getLaserFull function, yes, which is the one that we are using here in our new program, which is laser readings full. So what has this function special? Can you see something here special in this function? Can you detect something here special in this function, which has something to do with what we have been talking, of course? Can you let me know in the chat? If you use pointer minus minus, would it wrap around to the last element? I mean pointer with two minuses instead of plus plus. Yes, so the same way you can use plus plus in generations, you can use minus minus. So basically the difference is that if you use plus plus, you are going to move forward, and if you use minus minus, you are going to move backward in the array. Yeah? That's the only difference. Let me see the chat if somebody has told me. Is it a pointer function? Returns an address. The function returns a pointer. That's right. Very well. Very well. So this function actually, it's not returning an integer like it is doing this function. Well, this function in particular, it's returning a float. Yes? But this function here, it's returning a pointer, as we can see here. So this function is returning a pointer. So basically what it is doing is to get this array, the data array, which contains the 720 readings from the laser, and it's creating a pointer to this array, okay? And then it's returning this pointer. And why it is doing this? I could I could create here, let's say, an array, copy the data of the laser to this array and return the array, right? I could do this. So I could do, instead of this, I could create here an array. Let's say I could create, let me comment this. I could here create an array, my array, like this, and then return my array, right? So I could do something like this. But what's the problem of doing this? The problem of doing this is that I already have this data here. I already have an array here which has the 720 different readings of my laser, which actually it's lots of variables already. So I have an array of 720 different variables, 720 different positions. Yes? So by doing this, what I am doing is actually creating a copy of this into this new array. So I'm creating a duplicate. So basically I'm wasting memory. I'm using memory in something that I already have here. So what can I do in order to improve, in this case, in order to optimize, to make my program more efficient? So instead of creating a new variable and creating a copy of some data that I already have, what I create here, what I am doing here, is to just create a pointer which points to this array. So it's pointing here. Oops, I think I messed something here. Okay, yeah, here we have it. Yes, so it's much more efficient to just declare a pointer, make it point to this array, and then return this pointer. So now, in my program, I'm going to be able to work with this pointer, which actually it's pointing to this laser range data, which contains all the values of my laser, right? Then, in my program, I can work and operate using this pointer. So basically here I'm going to iterate using a for loop. Here, as you can see, I'm declaring a helper variable here, this e variable, which I'm going to increment it progressively using the plus plus element that we have, the plus plus operator that we have just seen, over all the 720 positions of my array. Then I'm going to be printing the pointer values and progressing and increasing here the pointer as well, right? So basically here what I'm going to be doing is using my pointer, I'm going to be printing all the elements that are in this array. Yes? Make sense? Then let me compile this actually. So in order to compile this, we are going to need to come here to the semi-list file. We can create a copy of this section that we have here at the end with the laser readings. I'm going to create a copy of this and name it laser readings full. Okay? So just copy these 4 lines and create a copy and paste them here and rename here the laser readings to laser readings full. Okay? Then I'm going to compile this. Sorry, I need to be here to compile. Catkin make. Let me come down here. Here you have the command that you can use once you have compiled and sources the Catkin workspace. You can copy the command directly from here. You can see here it's compiling. Then let me source my workspace. And before running my program, I'm going to reset the world using the following command. ROS service call gazebo reset world. You can do it as well if you want. And tap. And basically this is going to reset the robot to its initial position, okay? Then now, if I run the new program I have just created, laser readings full, what I expect is that the robot is going to move forward for 3 seconds, and then it's going to print all the laser readings, so all the 720 values of our laser array, yes, using the pointer. So instead, remember, the important part here is that instead of creating a new variable, a copy of this array, I'm using a pointer in order to access to this array. Yeah? Then, let me run my program. So the robot is going to start moving, and then it's going to print all the 700, I can see here, all the 720 positions of the laser array. Here I have them. Okay, so what I have done here is to use a pointer to optimize, to make my program more efficient. And this can be used for many things in robotics and in ROS. It can be used for laser data. It can be used for odometry data, for positions, for waypoints. So these pointers are going to allow us to access variables without having to create copies of them. Yeah? So it's going to basically make our program more efficient in terms of memory space. Yes. So it's going to make us not waste memory. It returns a pointer. Okay, yeah, I can see here all the function returns a pointer. Yeah, so does this make sense? Okay, does this answer your question? So this is a use of pointers, a very common, in fact, this is a very common and extended use of pointers in robotics, right? To make this kind of use of a pointer in order to optimize the memory used by your programs, right? All right, so we are already 10 minutes past the hour, so we are already 7 and 10 minutes. So thank you very much. Let me put here the chat. So we can have a pointer in odometry in order to take odometry points. Yes. You can use a pointer. You can create a subscriber to the odometry topic, and then create a pointer in the same way that we are doing in this program with the laser. You can do exactly the same with odometry. Yeah. So how did you call the pointer? What do you mean, Faisal? How did you call the pointer? What do you mean with this question? I'm not quite sure. Let me go back very quickly to the program. So here is where I have all the laser data, right? Let me show you here. Laser range. Yes. So this laser range is fulfilled here in the laser callback. As you can see, here is where I have the subscriber for the scan topic. The scan topic is where I am publishing all the laser data. Then here, I create a subscriber for this scan topic. The callback function of this subscriber is this laser callback, and inside this laser callback, I am storing in this laser range array, I'm going to store all the values of the laser readings. Then, what I am doing here is to, instead of creating a copy of this in a new array, in an array, for instance, what I am doing is to create a pointer which points to this laser range, right? And then I am returning this pointer. When I call this function, getLaserFull, I'm actually returning a pointer. So here, when I am calling this getLaserFull, I am returning a pointer which is pointing to this laser range. And this pointer, I am storing it here in the pointer that I have declared here. Yeah? So now, what I'm going to do is to use the pointer in order to operate with the laser data, which actually it's this one. It's here. Yes? In my program, I'm not using this laser range. I'm only using my pointer, as you can see. So I am accessing the different values of the laser using this pointer. Yeah? I don't know if this has answered your question. Faisal? Okay, so thank you very much, guys. I hope you have learned something from this live class. I hope you can take something. Remember that you are going to get this ROS jet, so you can keep working if you want now, keep practicing, checking, doing some tests in this program, modifications to I don't know, to keep testing and seeing how these pointers can help you. Yes, thanks, says. Great. So you can also, you are going to see that you have more information in the notebook. So how to declare constant pointers, for instance, or how to declare pointers to constant variables. You can have a look there by your own. You will find information in the notebook. So go ahead, please, go ahead. And yeah, thank you very much. I'm going to see you in the next live class next Tuesday. Thank you very much for being here with me one more time. And I will see you next Tuesday. Until then, as always, take care and keep pushing your ROS learning. Bye-bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof! Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.